Thank you very much, Helen. Hello, everyone, and welcome to today's 30-minute coffee break presentation. My name is Andrew Grinnell, and I'm the Senior Statistician here at Statistical Solutions. And over the next 30 minutes, I'm going to be showing you how to do missing data analysis in 3 simple steps using SOLAS. So if you have your coffee next to you, as I do, I will begin today's agenda. So, what we're going to do, the 3 simple steps that we're going to go through today is data exploration through SOLAS, data imputation in SOLAS, and also data analysis in SOLAS and also beyond. We'll also have time for questions and comments throughout and at the end of the demo. As Helen mentioned, if you'd like to give us feedback or questions or anything or comments, please feel free to put them through the text box. Okay, so the first step I'm going to go through here, step 1, is our data exploration. So when you collect your data from your survey, the first thing you need to do is gain some understanding of the data that you're dealing with before you can dive into any analysis. So what we're going to be looking at in this step is the missing data pattern, some margin plots, some mean comparison plots, and some simple descriptive statistics. So I'm just going to jump out of these presentation slides here and open up SOLAS. So this is what SOLAS looks like when you open it up originally. We have a file open window here where you can open an existing data set from various file formats through SAS, SPSS, Excel, CSV, and so on. Or you can create a new one. You can also view what we call our system preferences, so you can set up how you want the look and feel of the product to be before you dive into it. And we also have a script language window with SOLAS's own script language that I'll actually be demonstrating to you later on in the product demo. So what I'm going to do is open up a SOLAS file. I think I have it open already here. So this is the data we'll be looking at today. And this data set is a mock-up clinical trial data set where we have 12 variables. The first variable here is just the case or patient ID number. We have the duration variable, which is the time with the symptoms of illness for each patient, and this is in months. We have the age of each patient, and then we also have a categorical variable here of the age group, where we broke the age up into 4 different categories, ranging from less than 40s, 40 to 55, 55 to 65, and 65 and over. And then we have 8 dosage variables here, where we have a drug A measured at baseline, 1 month after, 2 months after, and 3 months after baseline, and drug B measured at baseline and 1, 2, and 3 months after. So, 1 second here. So this is our data that we'll be dealing with. We have 500 patients in this data set, and as I said to you, all we're looking at now is just a spreadsheet style format with a load of numbers. We don't actually have any understanding of the data at the moment. So generally, what the first thing we like to do when we know we have missing data is to examine the missing data pattern. So to do this, we just go View Missing Data Pattern in SOLAS, and then we have a drag and drop style format interface where we can drag and drop the variables of interest into the variables to display box. So I want to have a look at all these variables to see what kind of missingness has cropped up. And we also have a box here to define our longitudinal variables. We can split it by a grouping variable and so on. So I'm going to click OK. And now pops up our missing data pattern display grid. So we have a list of the variables that I selected earlier. And I can show you as well the legend where we have the blue cells represent a missing data pattern or value, and the white cells represent an observed value. Now this is quite a long grid, especially for larger data sets, so we have a nice feature where you can collapse this grid down to summarize the missing data pattern. So if I hit View and Collapse, it'll drop it down. So here's a summary grid of the data that we have. So we have 500 cases in total. As you can see, we have 390 complete cases with no missing data points. We have 10 cases with this particular missing data point, which is actually quite severe because we only have, as you can see, the baseline measurements for each patient in this particular row. And also, a nice feature of this is you can actually click on a specific cell here and it will tell you the number of cases and what variable the missing data points are in. We can also then split this or rearrange this pattern to show the monotone and non-monotone data pattern that I explained back in our webinar series on the strategies for missing data analysis. So here we have now easily outlined the monotone, which is in red, and the non-monotone missing data points. And what we do in SOLAS is we attack the non-monotone missing data points first, so we fill those in before we get at the monotone. And also when you're outlining your imputation models, you can define how both the non-monotone and monotone missing data patterns are imputed. So this gives us the first bit of understanding of how much missing data we have, where it arises, and how we should first go about tackling it. So as you can see here, all our missing data appears in the dosage variables after baseline, so 1 month, 2 month, and 3 month after baseline, which can be expected, and patients cannot show up for clinical meetings for a various number of reasons, and so this is quite typical of what can happen in the trial. What we can also view here is what we call the pairwise missingness report, and essentially it shows us a matrix of how the missing data looks in a tabular form. For example, duration by drug A1, there are 10 missing data points here, and so on. So this is also another tabular form of viewing the where the missing data has arisen. So that's just a quick and simple visual approach to exploring missing data and the pattern that exists in your data. Now what I'm going to move on to is show you how to examine missing data in the relationship between two variables. So in SOLAS we have what we call a margin plot, and here this is under the plot characteristic, or the plot menu in SOLAS. And for example, I'm going to plot drug A3 versus the baseline for drug A. And essentially this is a scatter plot with extra information given in the margins or in the axes. So as you can see here, we have a scatter plot where the blue data points here represent a value that is observed for both drug A0 and drug A3. And then we have down here in the x-axis we have both red data points which represent observed values for A0 but missing for A3, and also two box plots given, where you could probably tell the blue box plot displays the distribution of the observed data on this axis, and the red box plot illustrates the distribution of the missing data points on this axis. And we also have a number for the cells that have missing data points. So you can see here there's 50 actual missing data points here. We can also then re-specify this plot to break it down by a given categorical variable, and in this case we have the age group. So I have 4 age groups, and I can split that up into 4 separate plots, one for each age group, which I'm going to do now. So now we have 4 margin plots to illustrate in each age group where the potential missingness is arising. We can also see here that the over 65 age group here is pertaining to the widest spread of missing data. But we can notice here that the 55 to 65 age group actually have the majority of the missing data in one group, and it's very localized around the 210 to 220 dosage region. So this might be an area where someone might want to investigate further why that has cropped up. And again, this has given us some key insight into the relationship between these two variables just very quickly and easily using some nice graphical interface. I'm just going to quickly show you another example of the relationship between, for drug B, the same baseline versus 3 months after baseline. And again, we have a similar relationship here with the missing spread now being up higher. And if I replot that by the age groups, again we can see that there are several regions, especially for the plus 65 age group. There's several regions here that may be worth investigating further and would help towards building the imputation models. So finally, we also have some nice alternative plotting features such as black box plots, histograms, normal probability plots, just to give you an understanding quickly and easily of the data. And I'm going to show you just a mean comparison plot of the duration broken down by the age groups. So as you can see, the symptom duration is lowest for the third age group, similar for the lower two, or for the lower two age groups. And again, this just gives you a quick and easy understanding of the data that you're looking at. So what I'm going to look at now is the step 2, our imputation stage. So now we have some sort of understanding of the data that we looked at. Just quickly there, I've shown you some examples of how you can really mine into the information that you've gathered. So now you want to go off and actually deal with the missing data that you have. So now you need to perform some imputations and some post-imputation analysis. So I'm just going to jump back to SOLAS now, and we're going to tackle step 2, the data imputation step. So here, this is under the Analyze tab, and as you can see, we have a multiple imputation menu, and we have 5 methods of multiple imputation involved in SOLAS. We cover 3 types of approaches to missing data analysis and imputation. There's the matching models, where the matching methods where you try and find appropriate matches. There's the model approach where you model the data and trying to find appropriate imputed values. And then there's also the mixture model approach, which mixes both the matching and the model approach. So I'm going to show you an example of propensity score method, which is a matching method. I'm also going to show you a model method and a combination method. So if we click on propensity score, up comes our imputation window. And again, this is a very simple, easy to use drag and drop interface, and it's very self-explanatory. So we have a window here, variables that we want to impute, and then fixed covariates. Fixed covariates is where you outline how you want to define your multiple imputation model. And with the propensity score, these are going to be the characteristics that we want to compare similar patients on to find and unearth appropriate values to impute. And then once we find appropriate values, we set up a donor pool, as I explained before, and we randomly draw from that donor pool. So in this example, I'm going to use the length of duration of symptoms, the age, and both baseline values for both drugs A and B as the actual similar characteristics that I want to compare people on, and I'm going to use those to unearth similar values for both for the missing people, so that we can impute values. We have now 2 tabs have just appeared here, non-monotone and monotone, and this is what I mentioned earlier when we were looking at the missing data pattern. You can actually define for each variable, you can define how you want to impute the non-monotone. For example, I only want to use certain variables here to impute the non-monotone pattern of drug A1, and so on. Similarly, you can do the same for monotone. I only want to use, for example, similar variables here to impute the monotone pattern of drug A1. We also have a tab here for setting up the donor pool. So how do you want to create the donor pool? Do you want to divide the propensity score into 5 subsets and randomly select from those subsets? We can use the fifth top X number of closest cases. Here I've put in 15, or we can use the top percentage of observed or previously imputed closest cases. So I'm going to use the middle tab here just to use a subset of the 15 closest values to the missing person so that we can randomly draw from that a number of times. We also have then advanced options such as setting up a seed value. The seed value is very important for recreating the randomness and recreating the results, such as in the example for submitting to FDA, they would like to be able to recreate your imputations, so the seed value is something that's quite helpful in that matter. So going back to the first tab, the base setup, we also now can define the number of imputations. So it ranges from 2 up to 50 in SOLAS, and generally it used to be the rule of thumb was 5 imputations. Generally now it's 20 imputations because technology has advanced that a bit further. And just for demonstration purposes, I'm going to use 5. So I'll click OK now. I've set up my model and I've set up how I want the imputation to run. So I click OK. And now I've created my imputed complete data sets. So now this window looks the exact same as before, except now I have red and blue numbers, where the red numbers define the monotone values that have been imputed and the blue define the non-monotone values that have been imputed. Also, if you look down at the bottom here, I have now 5 tabs, one for each data set that I've created, because I created 5 imputed data sets. So that was just running a simple propensity score model. I'll do one more, and I'll do the combination method because it's slightly different. So I'll use propensity score, predictive mean matching, and Mahalanobis as combination method. Again, I'm going to set it up in the exact same manner. I'm going to use the 4 fixed covariates to define similar attributes and similar cases. And monotone and monotone I'm going to leave the same. Set up the donor pool using the top 15 closest cases. I'm going to leave the C-value and so on. Enter and exit criteria the same. I'm also going to run 5 imputations and create 5 data sets. So if I click OK again, it's going to run away. And now I've created 5 more data sets, this time using the mixture model approach and the combination method. So now I've got in less than 5 minutes I've created 10 data sets, 10 complete data sets using 2 different models quite easily and efficiently. So one nice feature I can show you here as well, which is a visual graphical feature of SOLAS, is what we call our post-imputation plot, and essentially what it is a scatter plot. And again, I'll do the same one as I did before. We have a scatter plot here where blue data points are the observed values, and now the red data points here are the imputed values from before. And as you can see, most of them here fit in quite nicely with the trend of the data. But a nice feature that we have added here is I can overlay the other 5 data points that I created for each missing data point. So if I click Show Multi-Imputation, Show All Points, now I've overlaid the 5 values I've created onto one plot, and the purple lines here show the spread of each imputation. So we actually have a nice fit here in this example. There's a nice fit there, and this is just visually. There are also other numeric approaches you can take within SOLAS to validify your approach. So this is the imputation step that we wanted to show you in SOLAS. As you've seen, I just created 10 imputed data sets very quickly using 2 very different approaches. and then I was able to view the imputed values overlaid on the scatter plot. So that's just the imputation step I wanted to show you. And finally now, the third step in our 3 easy steps is I'm going to show you some data analysis on imputed data. I'm going to do a quick regression example, and I'm going to show you then running some sensitivity analysis through multiple models on that regression example. And I'll show you the results of that as well on the slides. So I'm going to go quickly back to SOLAS again. So I'm going to open up the original data set again. So here's the original data set with the missing data points in it. And I'm going to do a complete case analysis. So I'm going to do a regression analysis here. This warning here is just telling me that I have a nominal variable and do I want to include it in the regression analysis, and I don't. And I'm going to, my target variable here is going to be drug A1, the 1 month after baseline for drug A. And now what we have popped up here is our regression window, and I've got 2 sub-windows in here, one for variables in the model and one for variables not in the model. So at the moment I have no variables in the model, and this is a very easy approach to take where you just click and drag the variable from one window into the other, and that's how we put variables in the model. So as you can see here from the p-value, which ones are significant or not at the moment, and this is going to act as a stepwise regression essentially. So I'm going to put in the most significant variables first. So that seems to be drug A0 and drug A2. And next seems to be, say, B2. And finally here I think we have the age variable. So at the moment here we have R-square value of 0.9, and we have our regression equation as such. So now if I move to my imputed data sets, so this 5 data sets here are my propensity score model. I created these with a propensity score model. I'm going to run the exact same regression model. So I'm going to predict our target variable is drug A1. I get the same regression window open again, except this time I have 5 tabs at the bottom and a combined tab because I'm doing this on my multiply imputed data sets. So I have one regression window for each data set that I created. And again, I'm going to go through the stepwise regression process of dropping variables into the model. So A0, A2, B2, and what's next here? Age. And again, there's nothing else left there, I don't think. Let's see. Oh yeah, and as I did this for dataset 4, it was also doing it for all the others. So here's dataset 5 as well. Again, similar result, nothing else. So we've created the same model using propensity score method. And at the very end, if I go to the last tab, which is our combined tab, we can see that the regression model, using Rubin's rules, we've gotten the mean coefficient value for each variable in the model and also the standard error. And as you can see here, the standard error associated with each coefficient value is quite low in respect to the coefficient value. So these are quite appropriate coefficient values due to the low standard error. So now again, there are also various other checks, validity checks you can do in SOLAS on that too. So last but not least, I'm going to go to my final step here is the imputed data sets, the 5 imputed data sets that I did using the combination model. And I'm going to do the exact same model again, going through the exact same steps. We have a regression window. I'm going to pick a different data set this time. And we're going to go through the steps one last time. So A0, A2, B2, age, and we have just this one crept in as well, duration, and drug A3. So now we have, in this case, 2 extra variables that have become significant in the model. And if I look at my combine again, I can look at the coefficient values, the standard error associated with those mean coefficient values. I can also see that the correlation is quite strong there too, and the R-squared values are quite strong. So these are 2, I won't say conflicting models, but as you can see here, we have 2 extra components that have come into the model by using the combination method. So now you can ask yourself, well, which model do I use, which one is most appropriate, and so on. So I'm going to go back to my slides here now to round up. So just by using a complete case method, we got the model using these 4 variables. Using propensity score matching, we got the same result. I didn't show it to you today, but I also used the predictive mean matching model, which is a regression-based model. We got these 2 added variables in the model, and using the combination method, the mixture model approach, we also got that. So what I wanted to outline here is that duration was always a complete variable from the word go. It's just when we used the complete case analysis, we dropped out extra information that we had already collected. And by using imputation, we brought back in that information that we already had into the mix. And in these 2 scenarios, it has become significant, and even this information has become significant as well. So this is a kind of a form we've already now done, and this is only in the space of about 5 minutes. We've done a sensitivity analysis using the multiple model approach, and whereas these are this is a regression model approach, this is a mixture model approach, and this is a matching approach. We can see that matching approach is giving us contradictory results to the other 2 methods. So that would give us evidence then to investigate the assumptions behind the matching approach. And in this case, because I set it up that way, there is the assumptions of the matching approach have been broken, and that's why there isn't these aren't coming through as significant. So that was just the main result that I wanted to show you, and also the potential of what multiple imputation and missing data analysis can show you using imputation. So just a quick recap there, because I know we've come up coming up on finish time, and I'm sure you're probably all coming to the end of your cups of coffee. So just what we covered today was we did some exploration. We viewed the missing data patterns, non-monotone, monotone missing data patterns. We looked at some margin plots to see how the missingness turned up in relationships between 2 variables, and we looked at some visual comparisons between the mean comparison plots and so on. We did some imputation, we did a propensity score matching and the combo mixture model approach, and then we did a quick regression example, and also I'll just quickly show you how to do export to SAS there. So this is dead easy. If you just want to go click File, Save As, and then we have all the data types here. So there's SAS for Windows, SAS 7 BDAT is what it's called. Click Save, and I can open that in SAS quickly and easily. Here it is, open in SAS. Ta-da! And there it is in SAS, ready to be analyzed and ready to be worked on from your SAS suite. So that's all that I wanted to cover today with everybody. If you have any questions, please feel free to put them in to the text box below. I want to thank everybody for attending. I hope you all found it informative and that you're now more you feel more comfortable with approaching missing data analysis. So we'll take a couple of moments there to answer any questions you have. Okay, so there are quite a few questions coming through, and thanks very much. It's always great when people get involved in the webinar. So we have one question here is, does the imputation process differ for missing categorical variables? And the answer is no. You can still do the same approach quite easily and efficiently, and there are, again, quite easily laid out for you in SOLAS for missing data analysis. I can send you on anyway some, and again we can forward on the answers to all the questions to everyone who attended, but I can send on some screenshots of those too. And also, how do you determine which imputation method to use? So that's a very good question, and again, it's a topic that's been discussed broadly recently. Essentially, with each imputation model approach you've taken, you have various underlying assumptions. So as I showed you there, we've had two sets of different results, not different but slightly differing, and if you go off and investigate the underlying assumptions, generally there are assumptions being broken somewhere, and that will kind of guide you in the direction of which approach to move forward with, and also always comparing back to the complete case analysis results as well to see how much you differ. So I think that's pretty much all we have time to deal with today. Again, thank you to everyone for attending, and I really hope you found this worthwhile and are more comfortable moving forward with missing data analysis. So again, feel free to contact me on the information on the screen there if you have any further questions, and we'll be sending out a recording and a copy of the slides to everybody. So if you want to review it again and contact us again, that's no problem too. So thank you to everyone, and we hope to hear from you soon.